All right, so in this chapter, what we're going to be talking about is light sources, actually. So what I've sort of been mentioning before is that light sources are the key elements, or one of the key elements to interior lights that differentiate it from exterior lighting, in the sense that there are many different light source options for interior scenes, and that need to be considered and that are important when dealing with them. So, with that being said, let's sort of take a look at this scene. And what I've actually done in this one is to make a very simple scene. I find it that it's much easier to do that. So, what I'm going to look at is basically this scene is, let's go into shaded view. A series of walls, and I put a little flare in there just because I was bored and I wanted some interest, but doesn't make any difference. I've got a wall, a series of walls, red, blue, and you sort of know why we're doing that. We've gone through that in the last exercise. And I've got a floor that I've tinted slightly, and I've added some glossiness to it actually, so we can actually take a quick look at that. You'll see that there's a floor, and I've added some reflection so we can take into account specularity, and I've got a little color because, again, I added something a little more interesting. But generally speaking, I'm keeping this really, really simple, and it's a good way to use or to think about when we're looking at very simple scenes, or when we want to look at our light sources, because it's going to sort of provide us with sort of a lab. And I'm going to use the same scene for many types of light sources, so I figured it might as well make it as simple as possible. And so we'll just go with that. So again, I've gone into camera view. We're going into camera view now. And what I'm doing is we're going to render these, and I've actually pre-rendered them as well. So let's look at the light sources. Okay, so I've got 3 banks of light, and I'm trying to make a slight variation on each one as we go through it. On this bank of light, this is actually a spot that just goes straight down, and you'll notice that I actually have an intensity of 5. I'm going to just go, there's going to be a reason why I have 5, and we're just going to stick with 5 for now. But I just have an intensity of 5, and that's it. It's just straight intensity of 5. There's no fall off, no decay, no nothing. And we'll just talk about that process as we go through. What's different about these lights is that this first one here has a beam, or basically a hot spot, that is 43 degrees and just 2 degrees difference to get the fall off of it. Also known as a penumbra. They would say a penumbra of 2 degrees here for the Maya users. And then here, this is another spotlight, and it's got a hot spot of 30 degrees and another 30 degree, or another 15 degrees on each side for its fall off. And then the last one is actually the important one, and this is actually the kind of light source that if you're going to use spotlights in your scene, just simple spotlights, start thinking like in terms of these numbers, where your hot spot's actually very small, about 10 degrees, and you get a very wide fall off, so it's got a nice big swooping light source, but which really soft at the edges. Okay, so we're going to go ahead and render this, and let's just take a look at our settings. Basically, what I have is I'm actually using adaptive subdivision here. You see I switched it out on you guys just to make things interesting. And I've actually turned off global illumination. So we're just going to look at this with straight non-global illumination lighting. And of course, it's not going to look really good at all. So you'll notice that basically there's no light that's bouncing around. You see nothing. And it looks extraordinarily bright because it's an intensity of 5, and when it hits that ground, it's 5. And here, you've just got light just going everywhere. You get this fall off that's kind of doing this, but it's still just, enormous amount of light, and that just goes all the way out here. So this isn't really, obviously, the way we need to look at, but nonetheless, let's look at the adding global illumination to this. So we do our indirect lighting. And what we're going to do is we're doing a indirect lighting, and then we're going to use this light cache. And remember, I mentioned light cache before. We will cover it again, but just to let you know, I'm going to be using light cache for this for these particular examples. And my radiance is set to high, 50/30. So I'm actually not even going to talk about rendering times. We're just going to start talking about the actual light sources in this one. This is really what we're interested in, is different light types. So with that said, we've got this, and then we've added the global illumination, and you'll notice that just that aspect has brightened the room considerably. Because this is an extremely bright source, and it bounced quite a bit of light, and then it bounced around, around, around. And so now that we've done that, you'll notice, okay, well, this zone is better lit, obviously, than the previous one, but it's also completely wrong. I mean, lights don't look like this in nature. They don't look like this either, and they certainly don't look like this. So what's probably happening is that these need to have, you know, some kind of fall off on them. So what we're going to do is we're going to go in here, and I'm going to go to my fall off, and I use this far attenuation, and I'm going to put on a show. Show actually will actually just take this back to wireframe. Show will actually show us the actual zones at which it's, you know, it'll full intensity there, and it'll slowly decay to 0 here. And I've done the same thing on this guy. And you don't have to use show. Show is just for the GL to look at it. And then again here, we're doing a fall off. And let's just see what that does. So we've got that, and then we've added the decay. Again, I'm showing this without global illumination. And then, of course, we do the same exact thing with global illumination. Actually, before I do that, let's talk about this briefly. This, you'll notice that it's already starting to look a little bit better. There's a decay here. This starts to look more natural. This is obviously starting to look more natural, not getting those ridiculous blooming here. But this is actually something you should notice, that it just sort of decays and peters out. This is where that circle ended. So there's no more light here. Which is, you know, basically, they should continue to be light going on here. So fall off is actually not necessarily the right way to go either. But you do get some glossy reflections here, which I kind of like. But that's sort of distracting. Okay, so when we add the global illumination to it, it looks a little bit better, obviously, and we're back in our zone, but it's still way too bright because these light sources are just too bright, and the light is just not kind of acting the way it should. So let's turn off the attenuation, and then what I'm going to do instead is I'm going to use this decay. So decay, light actually decays at a rate of inverse square. So what does that mean? That means that for every unit of distance that's out here, the light has decayed by that length in distance. The inverse of that length, the square of that distance inversed. So it's decaying considerably as we're going along. Never goes to 0, by the way, but it'll continue to decay. So I'm turning on inverse square on all of these. And again, like I emphasized, this is the correct way that light should decay in a scene. And we'll look at it without global illumination. I like to sort of go without and with. And you'll notice that now, all of a sudden, this is starting to look a lot more normal. And it'll decay, but it'll continue. And like I said, it never goes to 0. It just keeps decaying very, 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 very slightly. And this is kind of the way that lights actually work in nature. And we add global illumination, and it's just starting to look very natural in this zone. And because the global illumination sort of adds in all this fill, it'll slowly just naturally eat away at this light source. So it's just kind of just giving us exactly what we want to see in this in a light. And if you're going to use regular spotlights, which you should, you'll notice I said that this is probably the best way to go, and that's exactly why. That looks like an actual way that something would be lit. This is probably, you know, a more artificial spotlight. You never get this type of edges on lights. I mean, this is only 2 degrees, and look how sharp that looks. It just never looks quite right. So keep in mind, you're kind of more in these zones. Probably actually 99% of the time you're going to be in this zone in terms of using spotlights for interior scenes. All right, well, this brings me to an actually a more difficult subject that I want to talk about, and that's about monitor space. And this is actually sort of a side note or a side lecture of this particular chapter, and it's a very important thing that I want to talk about. And the reason I'm bringing it up in this chapter, because I think this is a perfect place to talk about it, because it provides such a great example of how to consider this. So when we're talking about this, what I've actually been doing this whole time, and I've been doing it on the previous chapter and the other chapter, so it's something to keep in mind. Remember when you see this that I've been doing this on the other chapter as well. Is I've been doing this under this Vray G-buffer color mapping, I've been applying this gamma correction, okay? And I've been applying a gamma correction of 0.4545, 0.4545, okay? And what that actually is doing, this whole thing, is actually applying a color correction to my image. And the reason I'm doing this color correction is that the way that Vray renders, and this is correct, is actually linear space, because that's the way the data of the lighting is actually true and correct. But the way what we've been doing is applying this gamma correction, which is the way your monitor works, to the entire image. But if I go back into linear mode, which is the way it actually comes in by default in Vray, so keep in mind that it comes in as linear and it renders as linear. If I actually go in here and I render this as linear, and I can show you what it would actually do, is I've actually brought it in and I'm rendering this in the actual frame buffer. This is a good thing to do. Keep in mind that, sorry, if I go to frame buffer, I'm going to enable built-in frame buffer, all right? When I render that, this is the way the image would actually look, all right? And this is an important thing to keep in mind. And you're saying, well, wait a minute, that's very dark, but this is actually the same image as what we've been looking at as this, except with linear, all right? So why does this not look right? Well, this is an important thing to realize. Let me go in here and let me actually save this image, all right? I'm going to go in here and I actually saved it already, but I'm going to go ahead and save it as stage 1. An important thing to realize is I'm going to save it as an HDR file, all right? And what an HDR file has the ability to do, if I go save and confirm, it'll ask me if I want to save it as a high dynamic range or a low dynamic range. I am actually going to save it as a completely high dynamic range image, meaning it's a floating point 32-bit image, all right? When I do that, I can bring this into Photoshop. And let's actually see it in Photoshop. So I got Photoshop here, and I'm going to open this. I'm going to open this inside of Photoshop, and this is Photoshop CS2, by the way. You'll see that even though I saved it like that, when I open it in Photoshop, it looks correct, because Photoshop understood this as a floating point image, right? And it also understood this as a that it needed to add the gamma correction to it, because it understands that this is raw pixel data, and then based on this color setting that you have here in Photoshop, I have a monitor space built into it. It actually added the correct gamma to my image. So now this looks correct inside of Photoshop. How do I get it to look correct inside of Vray? So what you need to do in Vray is you need this viewer, just the viewer, to be able to show you only in this viewport, not in the actual data of the image, what this would look like correctly. So if I go to this little button here in this Vray frame buffer, all right? If I go to that, it brings up a series of sort of color corrects that you can do. And this is only visually, this is not in the actual thing. So if I go in here and I put in a go up to about 0.6 here. This is a trick that my friend Rob Niederhosh showed me. And then I go in here and I make that free. It adds this curve to it. And that curve is going to approximately be equivalent to a 2.2 gamma. So in order to make that apply, you have to push this button. And you'll notice that right away, it looks correct. It's giving me the look that I need to see this image in. And but the data is still correct, meaning like this, but you're viewing it correctly. And you're probably confused at this point. It's like, well, I don't understand. Why is there two different states? Well, I'm going to try to explain this. It's been explained to me many times, and I think there's, I understand it, but, there's so many ways to try to explain this. But I'm going to actually try to explain this the way that I kind of like to explain it, and that's dealing with actual photography. Okay, so here's an example of an image. And again, if you don't get it, it's fine. I'll explain to you in the end what you need to do, because it can be a confusing subject. So, but let's just go through this exercise, and this can help some of you that may be on the fence about color space. I went outside and I took a picture, and this is a picture at 1/60th exposure, right? And this swatch right here sort of represents that exposure at the image, the average color of the entire image, all right? Then I took the same picture from same point of view and just one stop lower, which is half the light, okay? Half the light is 1/25th of the second here, okay? And that's the average of this. And then half the light of that is this. Then I take this same image here and I multiply it by 1 in Photoshop. It's very easy to do. Basically what you do is you take a color and you give it a value of white is 1, half of 50% gray is 0.5, and 0 is black. So multiply it by white is 1. So we've done this, and it gives us exactly the same image, right? And you see these swatches are the same. Then I multiply this image by 0.5, which is 50% gray, and I multiplied it by that, and you'll notice that even though it's half the value of this, even though it's one exposure down, this is darker than this, right? Same thing here, gone down half of this, it's even darker and it's even further apart, okay? The reason being that this is monitor space and this is correct, all right? So your camera actually sees things like this, but it adds the correct gamma to all these images as we're going along. So it's kind of, you need to be able to view it this way, but you need the data to be in this way, all right? And this is kind of the important thing to do. But basically it comes down to two different states. It comes down to a state where you want your data in linear space or you want your data in gamma corrected space, all right? So here's how you actually split that up. Gamma corrected space versus linear space, and when you apply which one. All right, so if you are going to work in linear space, or if you're going to work, more importantly, if you're going to work in floating point data, meaning an HDR, or you're going to work in EXR, EXR is also another great format to work with. If you're going to work in those type of spaces, what you need to know is that you need to basically set your color mapping to linear. And that's the way it comes in default, right? But when you're viewing things, you're not going to be viewing them correctly. You're going to be viewing them like this, all right? And the problem is, here's the big problem. If you're looking at things like this and you don't realize that you're looking at it in linear space and you should be looking in gamma corrected space, this is what would happen. So let's look at this very briefly. Okay, you remember this image? This was the image that we had in the previous chapter. If you looked at this and you applied it, you did it in linear space, it would look like this, all right? That is a linear space version of our image. What would be your instinct to do at this time? Your instinct would be to actually add more light. It looks dark, it doesn't look right. Notice also how much more saturated it is. So your instinct would be to add more light. And that's what you would do, and it would look just even worse. It's just so wrong to do this, okay? And this is the problem is a lot of people do this. They just keep adding more light to try to fill in their zones. They got all these artifacts. Then they've got to basically just like crank up their settings like crazy so that all this noise goes away. It's just a real nightmare, all right? What you need to do is you need to be able to render it so that it is in correct gamma space and it looks like this, all right? So what do you do to do that? You have to, if you're doing it in linear, if you're going to save it as a floating point image, leave it in linear, but then apply this gamma correction, all right? Right here. And then by doing that, just make sure you can actually see it like that. Right? Now, hopefully at some point one day, Vray will actually have a pull down and you can just say gamma 2.2, or maybe you can even save your monitor space like your ICM file. Doesn't matter. At some point maybe that will happen, but if that doesn't happen, this is a great way to go for now. All right? And now you'll be looking at it correctly. You won't have to worry anymore. And then when you save your EXR file or your HDR file and you open it up in Photoshop, it'll come in looking just like this, right? And if you do it in After Effects or Combustion or Nuke or Shake, just make sure you say, okay, I need it to be gamma corrected because this is a linear image, all right? Okay, now if you another big thing actually to keep in mind in this image, when I painted all those textures, right? I painted them and then I applied a gamma of 0.454545 to all those textures to make sure that they were in linear space, all right? Because when I'm painting in Photoshop, I'm painting in gamma corrected space. So I look at it and then I applied a modifier to make sure that all my textures were actually darker, because if you have nice bright textures, it's going to be too bright for this image. So make sure that what you see is painted in the correct color space as well. All right, okay, but you're saying there's no way I'm going to be able to work in floating point images. It's just too cumbersome, etc. I want to work in just good old 8-bit TIFF files, right? All right, that's fine. If you want to do that, that's fine, because that's the way you've always worked. What you need to do at that point is actually, let's go back in here, just turn that off, all right? And go in here and add this gamma correction. And then all your images will be saved with the correct gamma, with the correct curve as TIFFs, and it'll be just dandy. Everyone will be happy, okay? So keep that in mind this whole time, that you need to apply this gamma correction if you're using 8-bit images, because if you try to stretch the 8-bit image too much, you'll get banning. It's not too good. So always apply this gamma correction on your image if you're doing 8-bit image, 8-bit stuff. And then if you're doing a floating point image, then go back to linear, and then on your viewing LUT, just go ahead and apply this curve to it. Okay, hopefully that little side note, I know that was a little bit long, but something very, very important to keep in mind, and always pay attention to that. So let's go back now to our scene. I know we've taken a long detour. Let's go back to our scene and look at our light sources. Okay, so now we've covered we've covered most of the spotlight stuff that I wanted to talk about. So or just standard spotlight. So let's actually go in here and we'll turn these off. All right, and I'm going to talk about a different type of light source, and I'm going to talk about area lights, which are more are very appropriate actually when you're doing with global illumination, because area lights are more accurate to what lights actually are. So I'm going to go ahead and hide these lights, and I'm going to unhide these other lights, which are these area lights. I'm going to go ahead and turn them on. And these are basically just Vray lights, all right? And they just have a value of 5, again, same kind of thing. And the value of 5 is sort of distributed across the area. Few things to keep in mind when you're talking about area lights inside of Vray. The smaller the light, the less light it will emit, because the value is 5. It's not normalized across the intensity. If you want it normalized, you can just turn it on. But generally speaking, it's the bigger light, the bigger the amount of light coming out of it. So smaller light, bigger light, and what I've done here is I've actually made these little skinny long lights, right? So again, let's look at this, and if we rendered this without the without any global illumination like we've been doing before, it looks like this. So we have this very soft light going on here, and here in these zones we have these little pockets which are really nice. But what happens if we go ahead and add global illumination to this, and what that's going to do is going to look like this. So looks fairly natural and looks really good. Now area lights are becoming a very important concept when we're dealing with this, because they reflect correctly in the ground. They've got a great distribution of light, and they sort of act the way lights normally act in the real world. And you notice they actually render, all right? If I didn't want this to actually render in my scene, I have to go in here and make it invisible, and then it won't actually render in my scene. Unfortunately, when you do that, it won't reflect either, which is kind of a bit of a problem. But nonetheless, we need to pay attention to that. Okay, what we can do is we can look at what we're going to talk about now is a different type of light, and that's called IES lights. So what I'm going to do is I'm going to go hide these lights, and I'm going to open these IES lights. But I'm going to talk about them a little bit first. Okay, what IES files are, and those of you who are done, global illumination like Lightscape or have worked in architecture are probably pretty familiar with what IES files are. Those of you who've worked in feature films, unfortunately, I found that very few of you actually understand what IES files are. But this is built into 3D Studio, and Vray understands it, so it's great actually. I think Vray and Brazil and a bunch of other rendering engines all understand them because they're all, take advantage of the fact that 3D Studio is very good at dealing with them. If you go into a light source here, and you're creating a light source, if you go down to something called photometric, you can add these different types of IES lights. I'm just going to add one here just to show you its settings. What you'll notice is that it has this it has a bunch of different settings that are kind of very different to normally working lights. So let me actually undo that, and make sure I didn't actually accidentally add the light. I didn't. And so what I'm going to do is I'm going to unhide a series of lights here, and these are my photometric lights. And what they are, as you'll see, they're just actually called, I mean them 3-point lights. All right. And if I go to, let's turn them on first. That's the first thing, make sure we do. Always important. On and on. If I go to this first light here, it's got a bunch of settings under this intensity, okay? And the first thing it's done is I've added this distribution is according to a MED. It's not an isotropic or not a spotlight. It is done by photometric web, and I'm going to talk about that in a minute. And it's got a value that's here, and I've done this multiplier, and I'll talk about that in a bit. But what this web is actually a file. All right. If I go in here, you'll notice I'm actually opening up an IES file. So you're saying, well, what is that IES file? And that's an excellent question. What an IES file is the following. If I look at this here, all right, if I look at I'm using this little viewer here. It's called an IES viewer, and it's a great little free one. There's tons of free IES viewers out there. Just go on the web and look up IES file viewer, and you'll find it. Lithonia, I have a series of I have a library of IES files, okay? And Lithonia is a lighting manufacturer. They make lights for a number of things, anywhere from stadium lights to emergency lighting to lights that, wall washers to all kinds of different light fixtures, okay? So they make commercial lights for, architectural use or whatever, okay? Each one of those lights has a way that it distributes light, and that the way that it distributes light can be measured through and recorded and read as IES data. So let's look at that. Let's look at this IES light. And if I go in here, I can see that I have these different IES files. And actually, I think that the one I'm looking at here, which is 9580, I believe it's right here, that is that file, okay? The great one about this little viewer that I have here is I can hit this render button, and it'll actually render what that light would look like. And I can turn off this radiosity and turn it on, but it'll actually show me what the light distribution will look like and everything. This file, this data, is not an image, okay? And just to prove it to you, let's open it up in a text editor. All right, so if I go in here and I open it, let's go ahead and find it as, what is it, 9580, right? So if I go in here, and I'm going to open up in my TextPad editor, and you'll see that this file is actually a data file that gives me everything that I need to know about this light. It'll actually even tell me here all these little tags. It says it's Lithonia. It says it's an 8-inch open downlight specular reflector. Gives me all the information about the light, and it even tells you where to view the light link info. And it has this particular data file that basically data here that tells me the distribution of the light over the area, which basically translates into this graph, this editor here. And it tells me that this is the distribution of light over a specific angle, and it's actually 3-dimensional data. If I actually go into this particular light here, let me go in perspective view. It actually is 3-dimensional data, right? I can actually see it as such. And so 3D Studio is nice enough to give me that data. So I've got 3 different IES files, all right? And I've opened up 3 different ones, and you'll see it if I click on that one, it's a different file, etc. All right? And what I've done is if I actually go in here and I turn this multiplier off, which would give me its real value, I know that basically this has a intensity, and this is, these are real world sort of intensities. This is not like intensity of 1, 2, 3, 4, 5. This is called a candela, okay? So it's giving me a candela value of 1424, all right? That's basically telling me the intensity of light coming out of that light source. But I know from what I've been doing that this is actually not going to be good enough for my V-Ray scene. So I actually need to do a multiplier on this one. And I'm going to turn up that multiplier to 400. And you'll see that now it'll say resulting intensity is now 5694. So I can just keep going up and down, and it like, oh, I need it to be around, 20,000 or something like that, what I want. So you can do that way, which is kind of a good way to operate. So I'm going to turn that back to 400 because I know that I want around about 5,000 or so for this space. And this is going to be double. This is going to be that big, and it's going to be 3,000. So you'll see 3 different intensities. All right. So now let's look at this. If I rendered it without global illumination, it'll look like this. All right. So you'll see that you're getting all kinds of shape in terms of the light. The light now has much more shape. It is not just a spotlight. And this is because it's using these IES data files, all right? And this, like I said, this is not an image, and it's not just sort of making caustics. It's actually distributing the intensity across a 3-dimensional area, and it's doing it correctly. So when we look at this, this looks correct. And of course, we add our global illumination, and it's just much richer. Now, this is just so much richer than using spotlights. It's really basically the way to go when you're doing interior scenes. If you don't need them, that's fine. But especially if you have things like along walls like this, why would you ever use a spotlight when you can get so much richer zones out of things like this? Now, the great thing is I have tons and tons of lights. Tons. These are just the downlights, right? Tons and tons. And these are all free because Lithonia gives these out to their lighting manufacturers. That was the downlights. I have emergency lights. There are fluorescent lights. Just tons and tons of information. So it's very big, very important to sort of look at this. All right. So let's look at a few more examples. Like I said, we have tons of them. So let's look at a few more examples. All right. So to do that, what we're going to do is we're going to go ahead and just turn off these lights. Keep in mind, hiding lights does not turn them off. So you have to actually physically turn them off. Oops, that was just the shadow I turned off. That wasn't what I wanted. Turn that off, turn the shadow on, turn that off, turn that off. And I'm going to go ahead and hide these and open up the next series of lights. And these are going to be a little bit more different. I figured it'd be, let's look at something with a little more pizzazz to them, or a little different shape. So I picked some lights that I found in my library that are a little funkier. And a few things I want to note. If you look at this light here, it actually has more of a direction to it. And you'll see that. So what I can do is I can do this rotation. You see that rotation? I can actually rotate it in the right way that I need to rotate it. So you see, this is actually a wall washer. It sits there and it actually shoots the rays on the wall. And it makes sense. You've seen lights that do this, so that's kind of what it is. But it was at 180, so I'm going to actually shoot it on this wall. This one is a very sort of pointy little light, right? And then these are nice big wide lights as well. So again, I've added, you can look at the candela results I've got here. This is actually a fairly bright light, but it's fairly narrow, so it may not, look right. So I generally find that, you'll find your zones, and of course this seems like a really dim light, but we'll see how that affects our zones as well. All right, so let's look at this. And if we look at it without global illumination, it looks like this. And you'll see that the light is sort of starting to point this way. This one seems fairly bright. This is very much like a little spotlight like we saw before. Add global illumination, and it's, looks pretty good. In fact, remember that this was the strongest light source, but all of that strength is just sort of happening on the floor because it's such a pointy light as opposed to this one, which is much more distributed. Our wall washers could probably go up a few values. That's fine. But let's look at some other lights. And these are lights that are designed for interior scenes, but we can actually start, if you want to mess around, why don't you you have the ability to add giant lights in here. Actually, let's turn these off, because I remember, like I said, you don't, turning them off, hiding them does not turn them off. So we turn them off first, and then we will go ahead and unhide the other ones. And these are lights that are actually like these big outdoor lights. All right, these are actually lights that you use for like stadiums and stuff like that. But I figured it'd be fun. Like, why not just throw these in here and see what happens? These has got a really funky distribution on these lights. Let's go ahead and take a look at them in our viewer. So if I go to my Lithonia lights, I actually know that these are actually called. What are they called, actually? I think they're outdoor lights. Yep, outdoor lights, area lights, and then they're the AS, actually. So I've kind of memorized some of these. And you'll see that that's that light, okay? So that's that light over there. And if you do a render of that, you'll see it's got this real kind of very sort of caustic distribution here, all right? So this is a great way to like sort of preview all these lights you want to see. If you want to just look through them and say, I want a light that's like, oh, that's the one I want. In fact, that's the one I think I chose, isn't it? No, I chose this one, that one, but very similar. Anyway, there's a bunch of different ones. You can see that's a side light, and all these different kind of funky things. These are great to sort of browse through these lights. Anyway, so I picked these 3 light sources. But I also know that these are very bright. You see that one without a multiplier has a value of 4,000. This one without a multiplier has a value of 13,000. And again, this one is 12,000. Okay, so these are very, very bright lights. So let's see how that emphasizes it. Again, without global illumination, very bright. But it's got all this rich texture on here. I mean, you would never want to have this on an indoor scene. It doesn't make any sense. It totally looks like outdoor big lights in an interior space. And one thing I want you to remember, even though it said it was an area light, you're not getting area shadows. So you're going to have to try to find another way to get area shadows if you want to try to do that. But add global illumination, and it just emphasizes everything. You're getting nice bright spots or color bleeding, and generally speaking, this looks pretty good. I'm pretty happy with what we can do. I don't think it's appropriate, obviously, to have these lights. It was probably these lights were probably more appropriate, or these lights are probably more appropriate. But it's always fun to be able to play with IES lights and sort of get that feeling of what we're trying to accomplish in terms of these IES lights. All right. So last thing I want to do here is let's go ahead and turn these off again. And sorry, off. Could have made a filter to just select lights, but why do that? And I've got another type of light source that I want to show you, which is actually not a light source, but it is an object. So let's go ahead and unhide that, and it's these light objects. Okay. Now these light objects are actually a series of objects. Actually, look at them in smooth. All right, that I have applied special shaders onto. All right. And what they have is these, I've got a series of shaders on them that sort of do different things. And what I'm doing actually is I'm using this Vray light material. And what that actually does is it treats an object like a light source. So it has a color. You can even use a texture. Because it is an object, you can still use a texture. And that's actually what I've done on this particular one. Let's go ahead and look at that. If you look at these groups, you'll notice that on this particular one, I've added this texture, which is this gradient ramp, all right? And I've added that, so that's what gives it these edges. And on this particular one, I try to do something a little different for everyone. I've actually done 2 parts where the top part is just a base material and the other one is a globe, so it looks like a half globe. And then this is just a standard light that just goes across, just a fill light. All right. If we look at this without global illumination, all right, what we would get is the following. All right. just specular. Global illumination needs to be taken into consideration if you want to treat objects as lights. It needs to understand distribution. Otherwise, it wouldn't work. Okay, so you would just get specular, which kind of looks kind of nice, but you need global illumination on for that to happen. Again, there's no light source in this scene, and I just turn on global illumination, and it will actually illuminate the entire space through objects only, not through any light source. Okay, so this globe is providing, it's even providing shadows here. You can see the shadows that are happening. It's glowing on these edges. It's just, it works pretty well. So you can use objects as light sources. You can paint neon signs and everything else, and then all you got to do is you got to go in here, and then you pick a Vray light material. Okay, and then you'll treat it as a light material, and you can just go in here and say, oh, you can give it a color, an intensity, whatever you want. Okay, you even give it a texture. So really useful, generally speaking, to use objects as light sources as well. Okay, so we've gone through a whole series of different light types to use for interiors, and we're going to be using some of those later on in more practical ways. We've gone through the spotlights and talked about the different spotlights and how you need to take into consideration fall off or decay. We've talked about using IES lights. We've talked about using area lights. We've talked about using objects as light sources. And we even took a little detour to talk about monitor space. And again, I would emphasize, if you don't understand monitor space, just follow those last few rules that I said at the end, where basically either burn it into the image with the gamma correction in the color mapping if you're doing 8-bit, or just adjust your viewer if you're doing floating point. Okay, now we've done all that. Let's go on to the next chapter.